All right, so here we go. I want to start back now. Is everybody with me? We could do 26, right? All right. Now, I kind of asked you guys to give it your best shot, all right? Whatever it was, all right? I don't care. I think giving it your best shot, sometimes you got some right, sometimes you didn't know. A lot of them were just straight typing on your calculator in this section, so that should have been helpful. All right. So I want everybody right now to look on question number 26. All right. Does anybody even know what a CD case is anymore? Does everybody know what a CD case is? Right? Yeah. It's one of those little plastic things. So I definitely have to update my questions that I made up because CDs used to be popular. They were what the music was put on, right? And yeah, kind of like the DVDs, exactly. All right. So again, the CDs came obsolete once they had streaming music because why would you buy it if you can just listen to it for free? Okay. So for those of you guys who don't know, the CD is just is a case essentially. All right. So now it says the CD case is 3 inches or 3/8 of an inch wide, and a cassette case is 5/8 inches wide. If you want to put 8 cassettes on a shelf that is 20 inches wide, how many CDs? All right, so what I want to do now is, again, I think the visualization is super important. So I'm going to try to draw a shelf for you. All right. Now, in order to create the shelf, all right, what we're going to do is I'm going to try to do something like this. All right, where you can kind of see, hopefully, what I'm trying to demonstrate here. All right. And now this is kind of like what my shelf is supposed to look like. All right, not exactly, but good enough. All right, so it's kind of like a bookcase almost. Everybody with me on this? All right, so if I were to draw it this way, this is essentially what I'm trying to get. All right, so there's my case. All right, there's my case. Now, if I wanted to, again, we could kind of finish it off by drawing something down here a little bit more, and here, and then it's not exactly correct, but we would say something about like this. Alright, so hopefully you understand what I'm trying to draw here, just my little, there's my case, right? And it says I'm going to put things on the case or on the shelf, right? And I'm going to put 8 cassettes. So what I'm going to do is I'm now going to try to draw the 8 cassettes for you. All right. So here we go. So here's going to be cassette number 1 right here, right? Going to fit right in there. And then I'm going to put another one right next to it. Now again, of course, you don't have to draw this. I'm just trying to get you to visualize, right? So there's the next one. And how many more do I have? I have to draw 6 more. Right, so if I wanted to draw 6 more, we could just say, just for us right now, we'll just say that it's going to go to there. So all of this space right there is going to be for my what? For my cassettes, right? And how many cassettes did I put there? 8. So the question is, how much of the shelf did I use? Someone tell me how much of the shelf I used. Go ahead. Well, how did I do that? I'm asking you.
5/8 times 8.
That's exactly correct. Listen up, please, guys. Each cassette was what? 5/8 inches wide, right? And we just put 8 of them on the shelf. So I would want everybody to make sure that they just did what? This is just 5/8 times 8. Did I agree with that? And 5/8 times 8 would be what? 5 inches. So I've used 5 inches. Did I agree with that? So if I've used 5 inches, I have how many inches left to use? I have 15 inches. So now, please, all right, try to stay with me. That means from here to here, I want to do it that way. I'm going to do it this way. From here to here, I have 15 inches left. Everybody agree? Right? Because we already said the shelf was how long? We said the shelf was 20 inches. You agree with that? All right, does that make sense so far?
Yeah.
You,
So I get when you do it, like I get how to do it when you do it, but when you do it,
well, that's what you're practicing for. That's what everybody says the same. You're not the only one. Just take the practice, and you got to practice drawing it out, just like I'm doing. That's hard. I've always said this is a hard test, no doubt. Usually I say things are easy. All right, but you're gonna have to do some thinking here. That's hard. So what?
So when I did it, I noticed that a cassette case is 5 out of 8 inches, and a CD case is 3 out of 8 inches. And if you put one cassette case in one CD case, that's 1 inch.
Thank you for the information. All right. Here's what we got. I have 15 inches left. All right. I'm trying to figure out how many CDs can I put in that case. All right. So tell me what I need to do. That's exactly correct. The reason why I'm doing 15 divided by 5/8 is because here's what I'm trying to get everybody to realize. I'm doing what to this space right here? I'm dividing it up. That's what I'm doing. That's what you're supposed to be thinking about. Mr. Peak, are you with me today?
Yeah.
Come on, man. I'm up here. All right? So he said it beautifully. 15 divided by how many? 15 divided by how many? 3/8. Right, I know. That's okay. That's all right. You did everything right. All right, except just that last little step. All right. William, are you hearing me on this? Do you understand why I'm dividing? All right. So tell me what my final answer is, Austin. What did you say? Right. I could put what? 40 CDs on the case. All right. I put 40 in there. All right. Now again, like I said, I'm not expecting you to draw it that great. All right. Some of you are looking like you did even better than I did. That's true. All right. That's perfectly fine if you're drawing. All right. I think that just helps out. Hopefully you kind of agree with me on that. It's helpful to draw the picture out. All right. Very helpful. All right. So here we go. Number 27. All right. Read it. Come on now. Serious stuff. Okay, so this one's kind of tricky now. So what am I doing? Yeah, 12 because there's how many hours, guys? 12 hours, right? So it's going to go off. And what did we get for that?
16.
Right, so it goes off 16 times. All right, goes off 16 times. Shh, guys, quiet. All right, 16 times. Anybody have any issues with that? What? What am I supposed to do, Oscar, when you tell me this? You got this answer. It's different than mine. What am I supposed to do with that? Every day, this is why I'm frustrated. I'm asking you right there, that's how you do the problem. 12 divided by 3/4. If you're saying I'm not sure why you divided by 3/4, we can talk about why divided by 3/4. I have no idea how you did it. It's not the right answer, so I don't want to know. Look up on the board. The answer is 12 divided by 3/4. We took 12 hours, and the alarm goes off every what? 3/4 of an hour. So what am I doing with those hours? That's it. No, no, you're confused. We're not overthinking anything. You're confused. It's just 12 divided by 3/4. That's it. Well, that's the answer. 12 divided by 3/4. When nothing else needs to be said. All right? It's more confusing. This is what I'm looking at. This is from 0 to 12. I'm dividing those 12 hours into 3/4 of an hour. That's it. That's the best I can do. All right? Now, 28. Now, this is a calculator problem. What am I supposed to do on this, Mr. Danzy? What does that mean? I want you to say how you're typing it in. Well, I want you to write it. Now, listen, on your test, this fraction will be better. It'll be written like this. The line will be bigger. So you can clearly see it's just what? Stop speaking out loud. Yeah, I'm running a class. Say it again. That is exactly correct. So basically what I want you to be able to tell me is that just means 3/4 divided by 8/3. That's all that means. 3/4 divided by 8/3. Everybody good on that? All right. And so go ahead, Mr. Danzy. What was that? 9 over 32. I'm happy with you on that. Is everybody good with that? All right. Now again, I'm looking at some of your papers and I'm just not happy just seeing an answer written down, even though that's a what? Even though that's a what calculator problem. I would prefer this. This is what I'm preferring, that you put that on just in case you start studying over the weekend and you're reviewing and all of a sudden you may have forgotten how that happened. All right, that's why you write the information down. All right, to make it more clear. All right. Now, let's go. Number 29. Okay, 29, I really like this problem. All right, who gave 29 a shot last night? William, what did you say? No, I want to know what the answer is first.
6.
I got a 6. Somebody else? 6? 6? Wow. Maybe I was wrong about this problem. Maybe you guys just got it. What's on your paper?
6.
Okay. I want you to change your answer because
It
you
might be
think
4
everybody else.
though. I was thinking 6
6 cones. Thank you. That's even better. Never mind. That's an answer now?
Yes.
Never mind? Okay. I'd have to mark that wrong tomorrow. Never mind. All right. What?
4.
What's on your paper, I said?
6.
Okay, but you're writing 4 now. Okay, let's see. All right. So now, look, sometimes I put little trick questions like this on here, and I'm not saying you're necessarily wrong. I'm just saying sometimes you got to do a little bit more digging. All right. And why am I saying that? It says you're setting up a skating course that's 21 feet long. So here's what I'm doing. Please watch. What? I didn't say that was the right answer. So here's my course right here. It's 21 feet long. Hey, you're interrupting now. All right? It's 21 feet. All right? Now, generally, when you're setting up a course, right, you can put a cone at the first stop, right, and a cone at the end. That's why you have to be careful. All right? So here it says you set up an inline skating course 21 feet long to practice weaving around cones. You want a cone every 3.5 feet, but not at the start or the end, right? What? All right, now you're just setting up the course. So if this is 21 feet, I'm going to say this right here again is my beginning, and this down here is my what? This is my end, 21 feet, way down here. Now, I'm going to set up a cone. Do I put a cone here at the very beginning?
No.
All right. So is that a cone? Go there.
No.
No, it does not. All right. So here we go. So does a cone go right there? How many feet is that? 3.5 feet, right? So then another cone would go what? Right there. That would be what? 7 feet, right? And then what? This would be how many? 10.5, right? And then this would be 14. Is that good? And then this would be, what would that be? 17.5. And then this right here would be what? 21. Do I want one there? No, I don't. That's the trick to the problem. That's why I'm saying you have to be careful. The reason I'm trying to tell you now how you can think better now, listen to me. The reason why I knew it was different than the previous problems is because I wasn't starting what? I wasn't starting at here. And I wasn't putting one here. Does that make sense? Right? That's why. Listen to me. I asked you a question about where to put the cones. You told me where to put the cones. Now I count them and you say, why isn't it 4? Because why? Here's what I'm trying to say. Because I just drew it out for you. Some things, believe it or not, you just don't look at and say that's the obvious answer. That's what some of you guys are starting to struggle with. It's not just now, math is not just that's the answer, that's how you do it. The hardest part is trying to help kids learn how to think independently. This is what I'm saying. On the test, there's going to be problems like this where if you don't draw things out, you're just going to get them what? You're just going to get them wrong. That's just the way it is. All right, and I'm trying to show you how I'm not the best drawer in the world, but that's not too bad right there. Right? That's not too bad. What?
So it would be 5, but if you divide 4 by 3.
Are you listening to anything I'm telling him? What did I just tell him? I didn't say that. That has nothing to do with what I said. Nothing at all. What?
How would you put it if I'm doing
I'm trying to say, listen to me. There isn't, that's exactly correct. There isn't one at the beginning. You didn't put one at the beginning. But what I'm trying to say, William, and Oscar doesn't listen either, so that's okay. You weren't listening either, or you wouldn't ask me that, then you wouldn't ask me that question. Because what did I tell Austin? What did I tell him? If you were listening, you ought to, what did I tell him? No, that's not it. I said, listen to me. Although you can do 21 divided by 3.5, sometimes in math, if you get the operation correct, you're still going to be what? You're still going to be wrong because there wasn't one at the beginning, and you have to draw pictures. That's what the point of this lesson is. If you don't draw the pictures out, you're going to be what? You're going to be wrong. Did you hear what I just said? Did you understand what I just said? Putting in 21 divided by 3 1/2 does not make you automatically right. That's where the picture comes into play. There wasn't one at the beginning or the end. Now, let's say this. Let's say I wanted cones at the beginning and at the end. You know what most people would say the answer is? 6. But there's what? There's 7. Because if I put one at the beginning at the end, right, you would be adding 2 additional cones. Right? So that's probably what's going to be on the test. There's going to be a cone at the beginning and end, or there's not going to be a cone at the beginning and the end, and you have to figure out how many there are. All right? And now, the next question is, do you think it would be a fair question if I said it was, if I said there were 700 feet involved. Do you think that would be fair? No, because how many cones are you going to have to put down? A whole bunch. Does everybody agree with that? So would I ask you to draw a picture that's going to require you to put down 100 or whatever cones? No, we wouldn't do that. We always make the numbers small enough so it appears that you're what? Correct. That's the whole point. They make the numbers small enough so you go, wow, that was easy. The answer is 6. And then you move on. And you think you made 100 and you missed them all because you didn't do what? You didn't do what? Nope. You didn't what? Draw a picture. Or probably what? Listen. All right? That's the whole key. That's what I'm trying to show you. All right? Sometimes the just requires a picture to understand. If you want to be smarter, that's what you have to do. You have to draw the pictures out. All right? They're fascinating problems. They're very difficult. All right? They're very difficult, especially for people who think they're always what? If you think you're right, you're probably wrong. All right? That's how these word problems on some of them are. All right? So here we go. It says a ball is dropped from a height of 6 feet, and it begins bouncing. The height of each bounce is 3/4 the height of the previous bounce. When will the bounce, or when will the ball bounce to a height less than half its original height? So how many bounces will that be? Who can tell me? David, it's good for you. It would be 8 bounces. What did you get? 8. What did you say? 8 too? Wow, I'm pretty happy. 8. 8. Boys, what'd you get? Wow, girls up front. You're not sure? That's okay. 8. You got 1. Good. 2. That's good. 2 also. That's good. 4. See, the point is you have to draw the picture out and watch how we're going to draw the picture. I'm sorry. No, listen. Honestly, don't say that. All right? It has nothing to do with that. I'm going to show you now how I'm showing you. I'm not making you that much smarter. I'm just trying to show you if you draw a picture, things make sense. And that's the problem I'm showing some of you guys. It's not always just going to make sense. It's not always going to be easy. All right, so here we go. I'm going to draw this, and let me show you something. So a ball is dropped from a height of 6 feet. So here we go. I want to make my 6 feet. Right, so here's my wall. Right, and what I have here is I have this being dropped from 6 feet. So whatever you want to do, however you want to draw that, all right, here's the ball being dropped from 6 feet. All right, so now what's going to happen is you're going to roll the ball off, and it's going to hit the ground. Right, it's going to hit the ground. Right, so how far did it travel so far? It's traveled 6 feet. All right, so I have 6 feet right here. Then it hits the ground. Now I'm sure you know this. The ball hits the ground. Does it go all the way back up to exact height that it came from? No, it's always progressively getting what? Smaller. And you'll know that from your physics when you take that. All right, so how high did it bounce after it hits the ground? Everybody take out your calculator and tell me how high it went. What? How did you get that? It's 3/4 of. It's 3/4 of the height. In math, let's get this straight. What does of in math mean? Somebody tell me? If I said what's the product of 2 and 8, or well, that's not a very good way to explain that. If I said half of 10, what's half of 10? 5. We're just multiplying. 1/2 times 10. So what I always try to teach kids is that certain words in math help you decide what operation. Of is one of those words. So we can say of is what? Multiplication. of this multiplication? What? Okay, thank you so much. So what is, how high is the ball? Once it hits the ground, the ball hit the ground, I'm saying how high does it come up? It comes up to 4.5 feet. So now the ball is right here. So now my ball bounced up, it hit the ground, and now it bounced back up to 4.5 feet. So is that, take your calculator out. If you were listening, what does of mean? So multiply. What am I multiplying? Right? So multiply that. So now we're at 4.5 feet. All right. So from there now we say that the ball turns around and it heads back down to the ground. All right. So if it goes back down to the ground now, all right, here it goes back down, hits the ground, and now it goes back up. Is it going up to 4.5 feet? No, it's not going up to 4.5 feet again. All right, how high is it going now, William? Is that right? 1 1/3? How did you get that? What? Or you could pay attention, William. John, what do we do? But how do I get that? That's right. 4 1/2 times 3/4. So now I'm where at, John? Thank you, sir. 3 3/8. So now I'm reading the question. It says, I want to know, when will the ball bounce to a height less than half? Is it less than half yet? No, it's not less than half. Because less than half would be less than what? Less than 3. So now, is it probably going to be less than 3 on the next bounce? Yeah, it's probably. So the ball comes back down, hits the ground, and now how high up is it going? 2 and 17 over 32. All right. So how many times did it bounce before it reached a height less than 3 feet? 3 times. That's what I got. That's what I got. What? Because I told you, of in math means to do what? Multiply. Very good. What? Yeah. Or you could say, take your calculator out, because now you understand what I'm doing. Everybody take the calculator out. Now, if you understood what I'm saying, he said it perfectly. Type in 6 on your calculator, hit times 3/4. Is that less than 3? Times 3/4. You don't have to do anything. Hit times 3/4. Is that less? Times 3/4. Now is it less? And how many times do you hit times 3/4? 3. Isn't that nice, guys? Now you're learning how to use your calculator also. Notice you didn't have to keep putting in the answer. If you just hit times, it'll put up the answer from the last problem. All right? Now, let's go on to 31. What time we get out? I already forgot. So we have 11 minutes, right? All right, so we got time. Lots of good time. Here we go. So now, number 1, a water cooler contains 10 gallons of water. If you drink 2/3 of a gallon each day, how long will it last? Now, I'm hoping you're starting to get a better idea. It would be, but you have to tell me. What do I do? Yes, ma'am. Thank you very much. 10 divided by 2/3. And what does that come out to be? 50. Come on, loud and proud, kiddo. You're awesome. 15 days. It lasts 15 days. Now, again, if visually, yeah, come on. You're interrupting. We're not doing that in here anymore. All right. If you're not sure, again, think of the cooler that you get water out of in the cafeteria or whatever, right? And you're putting it into what? Smaller containers, right? So what am I doing to the big container? Putting it into the small container. What am I doing? Dividing it up. That's what you're supposed to be saying to yourself. So I knew I was doing 10 divided by 2/3. So it's going to last not 15 gallons. You're expected to be able to tell me it's 15 what? 15 days. All right? Now, here's that word. I'm not even reading, but it says 3/5 of the vote. Of means what? Multiply them together. So the winner for class president got 3/5 of the vote. If 200 students voted, how many people voted for the winner? What would I do?
So you do 5 times 20.
Wait a minute. What fraction am I doing? Right, okay, so hold on. I was jumping ahead. I didn't read it, so you're probably right, but I just was jumping ahead. So I want to ask you a question again. All right, so the winner received 3/5 of the votes. If 200 students voted, what fraction of the vote did the loser get? What fraction of the voter did the voter get? Yes, thank you. So the loser got 2/5 of the vote. All right, that's what you should put down. Now, how many votes did the winner get? How do I figure this out?
5 times 3.
Well, how are you saying 40? I'm not sure where you're getting 40 from.
Or 200 divided by 5 is 3.
Yes. But now, because you just said something multiplication, we could just do what? 3/5 times 200, right? So do that on your calculator. Do 3/5 times 200. That would be the winner. How much? 120. So the winner received 120 votes, right? And the loser would be 2/5 times 200, which is what? 80 votes. All right? So this would be the winner, and this would be the loser. Now you could have also done 200 minus 120. All right? William, this is what I'm talking about. You got to stay focused. You got to stay on track. Don't give me anything. I'm seeing everything that's going on. Trust me, at all times. I'm aware of what's going on. You don't have to explain to me what you're doing. I'm just pointing out that sometimes if you're distracted, I don't care if you have all 50 problems correct. If you're not paying attention, I'm going to let you know. And you're not paying attention. Doesn't matter to me if they're all correct. You got to be paying attention. 100% of the time, that's where some people have problems. Right, Oscar? Come on. All right, next. This was a really good problem. The surface of the Olympic oval ice skating rink in Salt Lake City, Utah was created by repeatedly spraying water to make 24 layers of ice for a total thickness of 3/4 of an inch. All right, does everybody understand, like, if you've ever been to, like, the Tampa Bay Lightning, right? They ski on ice, right? So, does everybody agree? I always wondered how thick does that ice have to be before they run out, correct? Everybody see what I'm saying? Because they're always skiing and they're always, kicking up ice all the time, right? So they figured out exactly how thick they need to make it so they'll have enough ice, right? So here what they're doing is they're saying there is what? 24 layers. Does everybody agree with me on this? There's 24 layers. 24 layers of ice. All right? And the ice, this length is 3/4 of an inch. I'm trying to figure out how thick is each layer. Tell me. 18 what? So if the whole thing is 3/4 of an inch, each layer is 18 inches. That's what you just said. No, that's what I'm saying. Now look, I'm always trying to tell kids also that absolutes are not always there for math also, right? I'm trying to give you clues to that. So again, although you picked out the word of, I'm going to try to tell you where you made the mistake at. Davis, do you have an answer to this? What are we doing? What are we going to do? Yes, we are. Are we going to divide 24 by 3/4? Are we going to divide 3/4 by 24? Most people think we're dividing 24 by 3/4 because 24 is bigger. Well, but look, here's why. Come on, I don't want you just, saying something because I said it possibly is wrong. What I'm saying is this right here is your block of ice. Do you agree? And there are how many layers here? 24, right? There are 24 layers built up. You see what I'm saying? But this thickness remains what? 3/4 of an inch. So what am I doing to the 3/4 of an inch? By what? That is exactly how you're supposed to be thinking. And notice again, guys, I'm not asking you to draw 24 layers. Right? I'm asking you to draw a picture big enough so you can understand the concept. So what was the answer if you did 3/4 divided by 24? What is that? It's 1/32 or 1/32 of an inch. That is correct. Thank you. Okay, so in this question right here, it says that there were 24 layers of ice. There were 24 layers of ice. It wasn't specifically talking about a unit.
I know. I mean the total thickness of
Right, this from here to here was 3/4 of an inch. That is exactly correct. I did what to that 3/4 of an inch? There you go. Easy as that. Did you not hear me say this? A lot of times, most of the times, of means multiplication. But some, if you're not thinking about the problem, you can be misguided. That's why I'm saying, show me your picture. Where's your picture? Yeah, it's not there. That's part of it. All right. All right, I think we're almost at the end here, guys. All right. So, somebody tell me what 34 means. What does 34 mean? Rivers. What does it mean? Yes, that's all it means. 5/8. This is what I'm trying to tell you. It means 5/8 divided by 5. That's a complex fraction. So type it on your calculator. 5/8 divided by 5. And what do we end up with? 1/8. All right. So William, what does number 35 say? That's exactly right. And what is that? Shh. Good. 20. All right. Now, I want everybody to take a look now. Here is just order of operation, right? For the next page. Flip that over for me. All right. So that's pretty much just what? Plug it into your calculator, right? Did everybody find this square button on the calculator? Right? There's a square button on the calculator, and it's generally this button right there, x squared. So if you want to square something, right? There's also this button on the calculator, caret 2. Some of you have that. Some of you have y to the x button also. All right, so there's lots of ways to do it because you have different types of calculators. All right, but most of you, I think, have the square button. All right, I don't think I asked you to cube anything up here. All right. So now, guess what I want you to try to do for tonight again? Study for your test tomorrow. Just kidding. All right. So tomorrow, listen, I really want you to do a good job reviewing or finishing up all the problems. All right. Then tomorrow I'll have a different worksheet for you, and we'll practice a little bit more. And again, if you had some trouble and you want your grade to be better, you should highlight your problems and then review those that you had problems with. Is everybody okay with that? Hopefully you're getting a little better. I know, some of you feel like you're not, but you are if you're doing what I'm asking you to do. All right? And you'll see when you take the test.